Hello everyone. So let us see the Millman's theorem. So with respect to electrical circuit analysis. So let us understand what is this Millman's theorem. So whenever we have more than one voltage source or current source, that can be written into the single voltage source or single current source. That is called as a Millman's theorem. So usually we try to convert our source shifting transformation, so that will make this n number of voltage source to a single voltage source. Let us take one example and let us see how this Millman's theorem will be applicable. So let us take the circuit here, so where it has a 2 voltage source. So it's a practical voltage source. So one voltage source with respect to in series with the resistance, and one more resistor, one more voltage source with series with the one more resistor. So just a second, we'll draw the circuit. One more resistor in series with voltage source, which is of opposite polarity. So the first voltage source, if you look at it, it's a positive and negative. The second voltage source I'm taking as a negative and positive. So then I have a current source parallel to that, one current source which is parallel to that, and the resistance parallel to that. So the current voltage source is 5 amps, voltage the resistor is 4 ohms, and there is a terminal AB across AB which will be having Rn J 5 ohms, R plus J XL. So let us write the values for this source and the resistance, which is of 4 volts, 8 volts, 3 ohms, 2 ohms. So this is a circuit given where I need to determine the current in this circuit, in this branch, that is I, through the 5 ohm resistor and J 5 ohms, using Millman's theorem approach. So to find this current through the branch or through 5 ohms and J 5 ohms, here let us write the terminal for this so that it will be easy for us to do the analysis here. So I will give the name as a terminal A and B. So within the terminal A and B, the current I is flowing. Okay. So first I will rewrite the circuit first. Okay. So and I need to open that current, the where the circuit the current I is flowing. So for example, I am making a note here. Let us take this as A and B. So this A and B node should be open. So because where I am supposed to find the current I. So I will read the circuit by opening that load circuit. Just rewriting the opposite circuit. So only change will be I am opening the terminal A and B. So writing with the given polarities as given the problem, and values of those voltage source as well as resistance, current source and the resistance, and opening the terminal A and B. I am keeping the terminal A and B open. So now here if you look at that, as I mentioned, if you have more number of voltage source, that can be written into a single voltage source. So here I have a practical current source. If you observe here, I have a practical current source which will be represented in terms of current source parallel to the resistance. I will convert this current source to the voltage source. So let us convert and rewrite the circuit, or shifting your current source to the voltage source. So converting the voltage source to the current source. So just I'm rewriting. So this current source will be in series with the voltage source. If when I convert the current source to voltage source, that parallel resistance 4 ohms will be in series with the voltage source. The voltage source value can be determined using the equation V is equal to I into R. So first I will write the values of these things, the other parameters, then we'll try to get what is the voltage of that voltage source. So V is equal to I into R. So where I, it is 5 amps which is given there, into R is 4, so it will be 20 volts. So after converting your current source to the voltage source, the voltage is 40 volts in series with the 4 volts, and I will maintain the terminal A and B open. So now there are 3 voltage source I can add easily, right? So here the Millman's theorem, it has a formula for finding that. So the value which is given here are the impedance, right? The Z is given for the problem, whereas the Millman's theorem requires the equation in terms of admittance. The equivalent voltage source can be represented in the form using the equation as a admittance. So where Vm the equal to V1 into M, because there are 3 voltage source, I am taking V1 as a first voltage source, second as a V2, and third as a V3, divided by Y1 plus Y2 plus Y3. So here Y is nothing but admittance, which is the inverse of impedance. So Y1 is 1 by Z1. Okay, so using that formula we can determine. Using this formula I can obtain a single voltage source value. Excuse me. I can get a single voltage source. So here Z1 will be equal to, so which is given as 2 ohms. So therefore Z2 equal to 3 ohms and Z3 equal to 4 ohms. So from this I need to obtain the admittance Y is equal to 1 by Z1, which will give the, if you do that 1 divided by 2, it will be 0.5 mho. So that is a unit of admittance is inverse of ohms. And Y2 is equal to 1 by Z2, it will be 0.333 mho. And finally the Y3 will be 1 divided by Z3, it will be 0.25 mho. So now once I know this Y1 values, I can substitute in the equation Vm. So V1, V2, V3 values are known from the circuit. I will substitute that 4 into 0.5 plus 8 into, so it's not plus. If you look at the polarity in the circuit, so if I go back there, if you look at the circuit, the polarity of 8 volts is given as a minus. So hence I need to take minus 8 into 0.33. Then the next voltage source is positive there, plus 0.25. So divided by Y1 plus Y2 plus Y3. So 0.5 plus 0.33 plus 0.25. So if I solve this, I will get the voltage here, it will be of 4 volts. So this is my equivalent voltage or equivalent voltage source. So once I get this, I need to find the equivalent resistance Rm, which will be 1 divided by Y1 plus Y2 plus Y3. That will give us 0.923 ohms. Solving this will get this answer. So now I will write this circuit using that Vm and Rm. So Vm we got as a 4 volts and Rm we got it as a 0.923. So it will be in series with the branch where I was supposed to find the current, that is we take as A and B. So what was at A and B? There was 5 ohms plus J5 ohms. I will write that 5 plus 5 ohms, J 5 ohms. So now I will add it back that element over there so that I can determine the current flowing through, that is I. So I is equal to V by R. We know that V divided by Rm plus RL. So that is on the resistance is load resistance RL. So substituting that, so Rm will be 0.33, we will get the answer as I is equal to 4 divided by 0.923 plus 5 plus J5, which will give the answer as 0.516 at an angle of minus 40.16. So this is a current flowing in the circuit. So hope so you got this solution. So how to determine the current using the Millman's theorem. So this is the answer for that given problem. Okay. Hope you understood this. Thank you.